Now let's see how can we use a base class pointer and references with a derived class object. As we have discussed previously that using derived class pointer or reference we can call a base class member function in our previous example. So in the previous example what we did, we have created a derived class object as well as derived class reference and as well as derived class pointer, and get value, the function which is not defined, not declared inside the derived class, which have inside the base class. So we can call this base class function. So now in this next example, we're going to see that can we call a derived class method using base class pointer and reference or not. So our example of the base class will remain same. We are not going to change anything in the base as well as in the derived. So in the last example also that we have saw that um, get name method is available in the base class as well as it is also available in the derived class. So same, it is also go with the same kind of example here also. Now let's create a derived class object. We have created a derived class object. We know what will happen in this scenario. When you call the getName method is available in the derived class. So derived class object will call the derived class version. Okay, so it will call the derived class version. Now look at the second call, get value. Get value is not defined inside the derived class. Get value is available here. So derived object will call the base version of the get value. Now at next, what we are doing? We are creating a base class reference. We are creating a base class reference and we are assigning the derived class object to a base class reference. And now we need to understand one very important concept is that, so when we create a derived class object will have two parts, base part. It will also have the derived part. Fine. Now, when you're doing this thing, when we are using a reference of the base class, what will happen? So reference that going to refer the same memory block because it is an alias. But we need to understand the most important concept. When we assign a derived class object to a base class reference, then base class reference is allowed to only access the base class part of the derived class object. So one more time I am repeating, try to understand. When we assign a derived class object to a base class reference, then base class reference is allowed to only access the base part of the derived class object. It cannot access anything from here. Okay, so when we are using the R derived is what? R derived is a base class reference and we are calling a method called getName. Now try to understand, getName is also available here, but we are using base class reference here. So when you are using base class reference, then base class reference going to call this getName from base part of the derived object. Okay, so base part of the derived object will going to return the name base, but in our last example we did the same thing with the derived class reference. At that time it returned us the derived, but here we are using base class reference, so it's going to access the base class part, not the derived class part. At last, what we did, we had call the get value method using R derived. What is R derived? R derived is the base class reference. So what will happen here? getValue method, although is not defined inside the derived class, so it is not matter of concern for the base class reference, is going to call its own implementation, because this part is also can access from this part only. It cannot access anything from here. So what will be the output that you are expecting for the second part of this main method? We are expecting that getName will return a value base and getValue will return an output only 5. Next, we have created a base class pointer and we are assigning the address of the derived class object to a base class pointer. Okay, so suppose we are creating a pointer here. Pointer of which class? Pointer of base class we are creating here. Base class. So base class pointer is pointing a derived class object. Okay, so suppose derived class object is have a memory block 2000. So this 2000 we are putting inside the derived class pointer. So now what will happen? It will also remain same as it is we have discussed for the reference. So when we are using a base class pointer can again only access the base part of the derived object. Means this getName will be called from the base part and getValue again is going to access from the base part of the derived class. So means in this example as compared to our previous example, that using base class reference and using base class pointer we are unable to call the derived class object, but opposite one is true, that using derived class object and derived class pointer we can call the base class versions. Okay, because base class is the part of derived class object and derived class has complete information about the base, but base doesn't have any information regarding the derived, so the opposite one is not true for the base class pointer and reference. In the next example, we're going to see a more complex example and we're going to understand why we need to use base class pointer and base class reference, because same thing we are achieving using derived class pointer and object and reference. Okay. Now look at the output here. See the output as compared to our previous code. The first one is remain same when we using a derived class object, but look at the last two output. In this last two thing we are using a base class reference and we are using a base class pointer here. So it's unable to call anything from the derived class. It's calling everything from the base part. I hope you get the idea that opposite relation is not true. That means base class pointer and reference cannot call a derived class object. We'll see another example in the next lecture.